So now we'll be graphing ax squared plus bx plus c. Even more specifically, it'd be y is equal to, but our quadratic function now has an a value, a b value, and a c value. So for example, I want to graph y equals 2x squared minus 8x plus 6. Instead of making a table like we've done for all of our other graphs, here's what I'm going to do. For any function where you have an a value, b value, and a c value in your quadratic function, here's what we do in order to graph. We want to list exactly what a, b, and c are. So in this case, a is the coefficient of x squared is 2. B, the coefficient of x is negative 8. And then c is the constant, which is 6. Now we can find the equation for the axis of symmetry. There's a formula that you could use, so definitely make sure that you write this down. You really should be listing each of the steps in your notes, but to find the axis of symmetry, the equation is always x is equal to the opposite of b over 2a. That's why we list a, b, and c. So the axis of symmetry for this specific equation, I already have what a, b, and c are. X is equal to the opposite of b. So b is negative 8. The opposite of that is positive 8 over 2a. So 2 times a, 2 times 2. And then you just do the math from there. In the denominator, 2 times 2 is 4. 8 over 4, 2. That's the equation for the axis of symmetry. X is equal to 2. Now we can graph the axis of symmetry. The axis of symmetry, the equation is x equals 2. So it's always going to be a vertical line. Here's my x-axis, here's my y-axis. I go out to 2 on the x-axis, and then I can make the axis of symmetry right here. I make a dashed or a dotted line, but that should break the graph up into 2 symmetrical parts. Now here's where you need to see how all of the different parts of the graph fit together. For the axis of symmetry, which is what I just graphed, x equals 2 in this case, the vertex will always be on the axis of symmetry. So we actually already know the x-coordinate of the vertex. The vertex, the x-coordinate in this case is x is equal to 2. So this is the line x is equal to 2. The vertex has to be on that. And then if I go back to the original equation, y equals 2x squared minus 8x plus 6. Here, a is positive, so the graph should open up. It's going to be stretched vertically compared to y equals x squared as well. But to find out the y-coordinate of the vertex, because I need to find the vertex, it's going to be a point. So I'm going to plug in x is equal to 2 into the equation to find the y-coordinate. So going back to my original equation, right up here, what I just circled, I'm going to substitute in 2 for x. So it would look like this, y equals 2 times x squared, so 2 squared, minus 8 times x, which is 2, plus 6. And then you just do the math from there. Again, we're following our order of operations. Exponents come first. 2 squared is 4. Then times 2 is 8. Negative 8 times 2 is negative 16, and then plus 6. So 8 minus 16 is negative 8, plus 6 is negative 2. So the x-coordinate of the vertex is 2. The y-coordinate is negative 2. So in this case, the vertex is at 2, negative 2. And I'm going to actually graph that. So I graph the vertex of the parabola. We're still graphing quadratic functions or quadratic equations, so the graph should be a parabola. Again, we figured out that a is 2. That's positive, so the graph should open up. Now here's what we can find. Okay, again, write this part down so we can find the y-intercept. The y-intercept is always going to be 0 and then c. So in this case, c is 6. I have to go all the way back up to step 1. So the y-intercept for this graph is 0, 6. And then I can graph that right here. I'm going by ones. So the y-intercept is 0, 6. Now here's what I'm going to do. I'm going to find the mirrored point is what I call it for the axis of symmetry. So looking at the graph here, it'd be a lot easier to see if you had graph paper, but the y-intercept right here It's 2 spaces away on the left from the axis of symmetry. So the axis of symmetry, remember, x has a mirror. So really, without having to input the value of x into the equation, you should know that 2 spaces away on the right, or in this case, the point 4, 6, should be another point. It's the mirrored point of this axis of symmetry. And then what I'm going to do is plug in one other value for x to figure out exactly the y coordinate. Here's where you kind of just need to take a look at the graph and figure out what you could plug in for x. Here I'm going to plug 1 in for x. So plug in one more point for x. To find y. Okay. So again, I'm going back to my original equation. I'm going to plug 1 in for x. The equation is, or was, y equals 2 times x squared minus 8 times x plus 6. And then if you do your order of operations, 1 squared is 1, times 2 is 2, negative 8 times 1 is negative 8, and then plus 6. 2 minus 8 is negative 6, plus 6 is 0. So when x is 1, y is 0. So I can plot that point. And then last but not least, sorry, I'm going to scoot it down so you can see that. I'm going to use that point and find the mirrored point on the other side of the axis of symmetry. Okay, so find the mirrored point from step 7. So on my graph, this point right here is 1 space away on the left from the axis of symmetry. If I stay at the same height, I go 1 space away on the right, and then my graph is a parabola. There's quite a few steps. We'll go over quite a few examples on how to graph other quadratic functions like that.